Hi everyone, I'm Rama here again. And the last video we talked about arithmetic progression. Where we said simple interest leads to arithmetic progression. So today we are looking at compound interest, in which we shall also see where this compound interest shall lead to. So now, talking about compound interest. The case we cite here is if an investor leaves both the principal and the interest on deposit in his bank account for a number of periods, such investor will earn interest on interest, which is referred to as compound interest. So, compound interest in a simple term is what is interest on interest. When you earn interest on on interest, so for example, I deposit money. I have money in my bank account, whether fixed deposit or not. I have money. Let's say I have money in my savings account with a bank. I did not withdraw the money. At the end of the period, whether monthly or as the case may be, the interest was computed on the monthly basis. The interest was computed, and the interest on my money I have there will be added to the money I have there. I did not withdraw the interest. So the interest has become part of my money. Also, if another period of time goes over that money again, that is the initial principal plus the interest, I'm going to earn another interest on the principal plus the interest, which it has accumulated there. So by that, therefore, any interest on interest is referred to as compound interest. Okay. So any interest on interest is known as compounding. Any interest on interest is known as compounding. The compound value, which is the future value or amount, can be calculated as, so for example, you now leave your money in a particular bank account for say a period of 5 years, or as the case may be, as you want it. How do you determine the future value? That how much should my money be at the end of the day? At the end of the period in which I'm going to do what I want to leave my money there, how much will it be? So let's go and see how much your money will be. So you can see all these things we are doing here is they are practical in nature. Because you can tend to have the money with the bank, and you can tend to know how much your money will be at the end of the day, at the end of the period. So if the bank is trying to play a fast game on you, you need to know. No, this is my money. This is what's supposed to be my money at the end of the day. So let's go. So the formula for calculating is is A is equal to P, open a bracket, 1, this is 1, plus R, close the bracket, raised to power n, called compounding. Where A is the amount in future, this A is the amount that the money will be in at the end of the period. P is the principal, R here is the rate, and n here is number of periods. Having said this, so let's look at the question. Let's look at the question to exemplify what we have been talking about. To practicalize what we have been talking about, let's exemplify it. Okay, so let this one go. Let me rub this. So let's leave the formula there. Let's leave the formula. Okay. We are still coming back to that. We're going to rub the formula anyway. It said assume the current salary of a civil servant is 500,000 naira per annum. P is per annum. What is his salary in the following 5 years? here is an annual increment of 20% on a compound basis. On a compound basis. Yes, this is the question. Assume the current salary of a civil servant is 500,000 per annum. What is the salary in the following 5 years if there is an annual increment of 20% on a compound basis? Now let's look at it. Let's say the following 5 years. So years 1, 2, 3, 4, 5. What is the formula? Z is equal to, so the total here, let's put the total volume, the total there. So let's do our workings here. So the principal, what is it? P for year 1, our P is what? 500, and this is our head here, 500. Open a bracket, 1 plus, what is the rate given to us in the question, rate of increment? So this rate, 20%. What is 20%? That is what? 0.2. That is it, 0.2, 0.2. Are we there? Okay. So close it. This is about what? N. N is our N here for year 1. N is 1. So what do we have? What do we have? What do we have? Let's compute it. So when you multiply, when you add this by this, we have what? 1.2. So 1.2 multiplied by 500,000. What do we have? We have 600,000. We have 600,000. We have 600,000. Now, we said is collecting interest on interest. So therefore, this is the interest. The interest on this amount is what it has been embedded here. You can see it's 500 here, but it's collecting interest of a rate of 20%. So what is the difference here? You can see it's 100. So that's 100 that's added to what is initial investment, initial salary here. So it is this is what is going to earn interest on in the second year. So 500 it is now what 600. It will now be what? We can also do it in that form. I will also show us another way in which you can do this. So let's say leave it there that way. 500. Let's see from the formula here. 500,000. 1 plus 0.2 raised to power what? Power 2. So 500,000. 1 plus 0.2 raised to power 3. In year 3. The following 5 in year 3. 500,000 plus 1 plus 0.2 raised to power 4 in year 4. 500,000 1 plus 0.2 raised to power 5 in year 5. So let's now get it one after the other. One after the other. Let's now get it one after the other. So 1.2, here we have 1.2 now, 1 plus 0.2, that was 1.2 is to power 2. So what do we have? Press it, 1.2 is to power 2, times upon there we have 720. We have 720. So 1.2 raised to power 3 times 700, we have 864. 864. 1.2 is to power 4 times 500. We have our calculator, please. 1 is 0. 1 is 0. 36. 800. So 1.2 is to power 5 times 500,000. We have 1,250,000. 244 160. So that is it. That is it. That is it. Or we can also do it in this form. You can also do it in this form in which you are going to have, you are coming back to this. So let's look at it in another way. The formula we gave us is, we said we keep receiving, the scenario we cited under the case is that you keep receiving interest on interest, interest on interest, interest on interest. Okay, let's now look at it. Year 1, 2, 3, 4, 5. Now for year 1, the first year is 500,000. Multiply with, you have 1 plus 0.2, 20 is 20% is to the power 1. What do we have there? We have 600,000. So this is what we have at the end of the year. So this is what I'll bring it to the next year. No problem. So 600,000 is to the power, what is what to the interest on it? So that is 1.1 plus 0.2, right? So you don't need to do what? In this case, there will be no need for you to do what? To put this power 2 here. There's no need for you to put this power 2 here. So what you are going to have, see, you are going to have what? Your 720. So bring out the 720. 720. 1 plus 0.2 plus 0.2. Definitely add this to it, sum it. So we are going to have 864. 864. Okay? 864. Definitely that's what we're going to have. 720. Yes, 864. So you bring down the 864. 864. Thousand. So 1 plus 0.2. 0.2. Then we have 1,036,800. So bring it down. 1,036,800. 1 plus 0.2. So we have 1,244,160. So we still have it. If you're doing both ways, you are going to get the same answer. You are going to arrive at the same answer. So 1, 0. So 1,036,800. So that's another way in which you can solve the question. That's another way in which you can solve the question. So from here now, compound interest normally leads to what we know as geometric progression. Compound interest normally leads to what we know as what? Geometric progression. On and on like that. We multiply itself, multiply effect. So on and on like that. So our next discussion will be on geometric progression. So keep watching and stay tuned and look for and watch out for our next video on what? On geometric progression. Thank you.